all going to need to get familiar with this stuff. This is an attempt to give you at least some baseline familiarity with what these things are. Some of the people in the room, I'm sure, are probably already quite familiar with these terms and topics. You will recognize that I've oversimplified some things. The rest of you have no familiarity with this at all. I'm going to try to bring you up to a basic literacy level. Understand that that is a little simplistic, but you'll have enough knowledge to be able to carry on and learn more about what's going on, and that's the purpose of this today. One of the most fundamental concepts of the internet, from its beginning, has been to push the intelligence to the edge of the network. In the early days, that meant all the way to the host, the connected computer on the internet, and that there was really no intelligence at all residing within the internet itself, within the network itself. This was very, very different from the way networks had been built to that previously. If you think about mainframe networks and things like that, you had, terminal controllers and cluster controllers and all kinds of, hierarchical I/O controllers that were all really smart computers in their own right. Now, the internet has evolved in such a way that's still happening, but in different ways. And it'll be interesting to see how this happens. One of the big trends, though, is peer-to-peer is almost always favored, and hardware is often replaced by software, and that's really what this whole talk is about. Software, it really is eating the world. This is something that Mark Andreessen wrote about in a famous Wall Street Journal article back in 2011. I encourage you to look it up and read it, because he's right. Every company is a software company, whether you recognize it or not, whether you like it or not, whether you want to be or not. Every company today is a software company. You better acknowledge it, you better get good at it. What is software? This is the best example I've ever heard. It's the expensive part that's hard to change as distinct from hardware. Okay? Developing software is not cheap. It is not easy. It's something that we're all going to have to do. By the way, apologies to Byron Reese and his excellent book, which I started skimming a little bit last night. I do think this is one of the 2 best books ever written about computers and information technology. It's a very hard book to find. It's been out of print for a number of years. If you can find a copy, you'll pay over $100 for it. It is completely weird. I will warn you of that. If you find a copy, be prepared to have yourself blown away a little bit by some of this. It was written in 1974. He also wrote something else that I want you to keep in mind, and that is that everything is deeply intertwined. And that is very much the case with what we're going to see here in SDN and NFV. Keep that in mind too, because everything is intertwined, and everything that we're going to be talking about and everything that's going on in modern networks really is like a bowl of spaghetti. Everything is connected to everything else somehow, some way. Virtualization has changed the world. In the data center world, especially in the past 10 to 15 years, we've seen absolutely huge changes. This is an example of Microsoft, Facebook, and Google who do this. Amazon is actually in a class all their own. 16 times faster configuration upgrades, 4 times faster application deployment, 40% overall total cost of ownership savings, 12 times faster troubleshooting and issue resolution. Every single one of you, every single one of your companies, every single one of your businesses is going to be using these techniques that we're talking about in the next few years. We talked some yesterday about why that is. The various pressures you're under. I think actually yesterday's panel discussion was the most frightening thing I've heard in a long time. Because we had a bunch of people up here from all the various carriers saying, we're going to go do this, even though we know it doesn't make any money and we're going to have to find other ways to make money to pay for all this. All right, that terrifies me, number one. But it also tells me you have absolutely no choice but to deploy these technologies on a very large scale. Virtualization, the basic idea is actually really simple. In a conventional system, you've got your application running on top of your operating system, running on top of your hardware. We're all familiar with this. This is the way our PCs work. It's the way computers worked for decades before this. Okay? In the data center, we're seeing something completely different start to happen. And some of us do this. I actually do this on my PC, or did until Microsoft handily included Linux in a recent update to Windows. It is there, interestingly enough. You wind up having the hardware and something called a hypervisor, which is a virtualization layer that is put on top of the hardware. There's 2 kinds of hypervisors. Some of them run on bare metal, directly on the hardware. Some of them run on top of a host operating system. And then they provide what looks like the operating system as a service and you can actually run a complete operating system on top of this. And so you can have your application operating system stack virtualized separately. This was done first in the data center environment because 10, 15 years ago, every application vendor said, oh, sure, we'll support you, but only if you run our application on its own server, because we can't be responsible for what somebody else is doing. And so that started to get really unmanageable. Okay, you mean every server has to have its own stinking computer? All right, well, this was the first time we started to see racks grow. This is changing and doing it, everything's virtualized now, pretty much everything, and it's growing. You're seeing more and more things become virtualized. This is a big revolution, though, because the network guys haven't done this. Up to this point, this has been done primarily in data center, primarily in computing. We're starting to see this happen and affect what's going on in the real world, and that's the exciting part of this. Continuous integration is a huge deal. Fast deployments of new applications are a huge deal. One interesting observation, the original internet did use host-based routing, meaning that there were no dedicated routers. The first versions of the internet just used computers with multiple Ethernet cards, and it was like, okay, I'll run a route daemon and swap between those. The interesting thing is we've come full circle. That wasn't fast enough, so we went with custom hardware and application-specific integrated circuits that sped all that stuff up. But we've come full circle to the point to where commodity CPUs and GPUs and I/O processors and all kinds of other things are fast enough to do host-based routing again. And that's really interesting because it opens up some new possibilities that we haven't seen before. This is actually a quote from the history of the internet. With the role of the network reduced to just the bare minimum, it became possible to join almost any networks together, no matter what their characteristics were, thereby solving Kahn's initial problem. Kahn is Robert Kahn, who hired a fellow you may have heard of called Vinton Cerf, who is generally regarded as the father of the internet. It was not Al Gore. There are a lot of, I'm calling these meta drivers because I don't know what else to call it, but these are things that are driving this entire large trend to this. It's growing like mad. Better utilization is essential of everything, okay, for the reasons that we talked about yesterday, all right? I learned one really useful thing yesterday, and that's that 5G is actually nothing except LTE continued, okay? But I guarantee you one thing, and we talked about it yesterday, everybody's going to want 5G because it's one more, okay? It's one closer to 11, and we're going to want to get there. The pace of technological innovation is quickening. We saw this yesterday too. Market and customer demand gap to the state of the art is closing. I actually don't envy some of you who are working in the carrier market because you're being pushed so far, so fast to provide new things that it's really, really challenging, I think, to stay up with this. And the customers are wanting more advanced stuff all the time. They want that 5G, you know. Like I said, general purpose hardware, CPUs, fast enough to do a lot of this stuff now. Cloud data center market has created a whole new arena of hardware devices, what are called white box devices that are much more generic, okay? There are vendors now that do this stuff that you've never heard of, okay? Large companies actually don't buy servers anymore. They have their own made for them, okay? Facebook has its own switches made for it. Google has a lot of its own hardware made for it. Amazon builds darn near everything on their own. The rest of the world uses 10 gigabit and 40 gigabit Ethernet. Amazon uses 25. Why? Their engineers are smarter, okay? One of the reasons for that is that 10 gigabit Ethernet is the basis for 40. So 40 gigabit Ethernet basically winds up being effectively 4 times as expensive as 10, all right? 25 gigabit Ethernet is the same cost as 10 gigabit Ethernet. Therefore, they can get 50 for only double the cost that relative to 40, all right? Smart stuff. Standards are maturing rapidly, and don't miss this next one, okay? This is actually one of the hugest meta trends here. Open source is absolutely winning this war. It's absolutely driving this war. The days of proprietary systems, platforms, and software to do this stuff are over. And everybody that's playing in this field recognizes it and realizes it. Nobody has the resources to go it alone and get anybody to adopt their platform. That is a huge, huge change. It's been a long time coming. The success of Linux made it inevitable, but it's finally here. So these are all things that are happening that are driving this. These are all emerging technologies that are coming up at the same time, and they all play with one another well. I disagree with this slide some for a couple of reasons, but it does show that they're showing a lot of huge growth here for software-defined networking and for network function virtualization. And we'll talk a little bit, I've got to get into what those are. Momentum is building. This is actually really interesting here. I'm going to hit this one just for a little bit. Later this year, AT&T is doing something really interesting. By the way, pay attention to what AT&T and Verizon are doing, because they're the leaders here by far. AT&T has this eComp deal, which they have not really talked about a lot. You're going to be hearing a lot of noise about it later this year as they open source it in conjunction with the Linux Foundation. This is what they're using to virtualize 75% of their network by 2020, as was talked about yesterday. Verizon has also done some really interesting deployments here using network function virtualization and OpenStack across 5 of their data centers. And this is actually a key point. This is from Chris Emmons of Verizon. The network can actually be even more reliable even though you're running on what's theoretically less reliable hardware underneath. It's not theoretically, it is less reliable. But we know this works. We know this technology works. We know this concept works. It's the same concept behind RAID and disk arrays. Okay? You have a lot of unreliable stuff. You know they're going to fail. You plan for them to fail. And you build the system so that when something fails, it just gets swapped out with something else and nobody cares. You carry on. Okay? It's gotten to the point today where really large data centers don't bother to fix servers. It started out nobody bothered to fix hard drives. Now they don't bother to fix servers. They don't bother to fix racks. In really large data centers, they use pods now that are made out of shipping containers, and they don't bother fixing anything until they replace a whole pod. Okay? When things die, you just leave them there. Let them become fossils, mark them as unused, and go on, just like you would a bad block on a hard disk. The 20th century way, and this really is a difference between the way that we did things previously. It's this big a difference. It's a huge shift in paradigm between the way we used to do things and the way that we're going to do things for the rest of the 21st century and maybe beyond. These were all proprietary vertical stacks of stuff. You had proprietary silicon, which was really neat. It was really fast, but it requires really big companies with really big resources to produce this stuff. And they've got to try to find the support resources and support resources to sustain that. These things take years to develop and produce and get in production. It's not very agile, okay? And you had proprietary systems and network OSs and features and stuff, and you were locked into that. And some of that stuff didn't really change. With the virtualization, again, this is more on the IT side, but it relates to networking as well. You've got all of these things here where you've got commodity silicon, commodity hardware, you know, either branded or white box, Supermicro, a lot of you may have never heard of. These are one of those great white box vendors. They were a Taiwanese ODM, that basically has become a huge player in the server space. Consumers don't have any idea who these guys are, all right? But a lot of your data centers run them, all right? Operating systems, we don't care. Everything's virtualized anymore. Whatever you want, you've got VMware KVMs in, can run Linux, can run Windows, can run whatever. And then all of this automation and management stuff that's going to sit on top of it to do really neat stuff. I also think this is going to be a game changer. When ARM really gets into this server space, which they're starting to do, this is going to change the game again. Because Intel and x86 architectures are still primarily the technology that is being used to do this. They're very power hungry. All right, when you look at these, look at your phone. Compute power versus power consumed, there's a huge difference. Network provisioning hasn't changed. The only difference is you used to do it over Telnet, now you do it over SSH. This literally hasn't changed since before my daughter was born. She's grown out on her own and has a great job. Okay? SDN was originally created for academic cloud and data centers. The primary exponent there in terms of organization is the Open Networking Foundation. NFV has been created by the service providers to solve a problem that they have. We're going to talk a little bit about those here in just a second. What are the differences? And this is where we really kind of get into the meat of it. SDN at its core, and we'll talk about some more in a second, is separating the control plane from the data plane. And up to this point, we had hardware, router, appliance type devices that consolidated those. The control was built into the firmware that went with the box, all right? And the switching was built into the hardware that came with the box. So you couldn't really separate those out. NFV is used to create a bunch of network services and optimize and virtualize those themselves, okay? Network functions such as DNS, caching, security, all kinds of things, all right, can now be separated and just run in software on top of virtual operating systems, virtual boxes, virtual environments, or containers in a distributed virtual environment. Network virtualization, I'm not going to talk about too much here, but this is something that actually has to happen primarily within the hypervisor virtualized environment. That's not just within a machine anymore. A lot of the more complex ones have the ability to virtualize networks across boxes, across the data center, across the globe, actually, if you want to. Amazon lets you do this across the planet. White boxes are obviously just, this is the generic hardware that's letting people do all of these really interesting things. You've got three components here. The application plane, this is your business applications, or in the case of NFV, your actual network applications that are doing things within your network. The control plane itself has the SDN controller, and you'll have the data or infrastructure plane, which contains your switches, vSwitches, routers, whatever, all of your other stuff to be able to actually connect things. These are there are defined APIs between these in the SDN architectures. There's what they call the northbound API, which interfaces with the applications. This is much less mature at this point. And there's the southbound API, which is actually pretty mature now after several years, that is connecting the control plane to the data and infrastructure plane. And this next slide shows you some of the protocols that are being used to do this. So we talked about ETSI there, the telecom standards guys. They're working on network functions. This northbound API is being attacked by a lot of people, but one of them is OpenStack, which is one of the popular ones. The SDN controllers are, again, more than one place, but Open Daylight is a popular one. Almost everybody worldwide, it looks like the whole industry is kind of settled on OpenFlow as the primary southbound API. Again, there are others, but OpenFlow is building huge momentum, and it is open. You will notice these are all open protocols. Okay? There is no vendor proprietary, no carrier proprietary stuff here. In some cases, the carriers have built their own things to be able to fill gaps. But the primary tools here, the primary platforms, are extremely open. You generally are doing this to have logically centralized intelligence. In some sense, this is fighting against that internet model, but it's also working with it. You still want to keep the intelligence as close to the edge as you can get it, but maybe not all the way at the edge. There are cases where it really helps if I can be a little smarter about what's going on in my network. Abstraction is one of the big ones. This is one of the ones that gives you the flexibility and the ability to move fast. Some of the things that are going to happen here as far as the success are attempts to centralize too much will almost always fail. Some of these are just kind of takeaways for thinking about this, okay? This is still at least equal parts art and science. In fact, it may be a little bit more black art than anything else at this point. We're figuring out how to do these things. No one knows how to do this well, especially on a really large scale. The people who do know how to do it best on a large scale are in very closed environments and don't necessarily always talk about what they do. Okay, that would be actually Amazon, Google, and Facebook primarily, although Microsoft and some others to a slightly lesser degree. And another thing is, determining who and what gets to set which policies and how is going to continue to be an issue. In fact, it's going to be a bigger issue because right now in a lot of organizations, you already have people who are responsible for those things. And they know how to do this, doing things the old way. And everything is changing. So you're going to have some interesting turf battles going on in your organizations because what's going to happen is the people in your IT organizations, the people that understand DevOps, the people that understand continuous deployment and integration, those people are actually going to be way better suited to run networks than the people that know about networks. The problem is those people don't know anything about networks. All right? And so that's going to be a real challenge and a real problem for everybody involved. And the last one here is an interesting point. All right, don't forget this. You are using new power tools, and power tools can kill. Everything is configured by software. Today, half your network is configured by what's connected to what, by wires and cables and whatnot, fiber, whatever it is, okay? In this world, all those connections happen via software. I can make a change, and boom, it happens instantly across my entire network, all right? I can really screw stuff up that way. Really, really bad. Really, really quick. Really, really effectively, okay? This is kind of the benefits and drivers. One of the big reasons that people are looking at doing this is it's a huge reduction in CapEx and OpEx, flexibility, agility, and simplified management. A lot of what's going on here is we're automating management. It has to be automated in these environments because it's too complex not to be. And that's more or less what this slide says. faster paced innovation, agility. WAN link utilization is a huge one. Google has gotten their WAN link utilizations to 95% or better. Most of theirs are above 95% today. That's a huge deal because you're paying for those WAN links whether you're using them or not. So if you're in a situation where you own those things, this is huge, okay? The things on this slide and the last slide are possible without SDN, but they're much more difficult to do and manage. I'm not going to do this. I'm not going to talk about this one except to point out that we're going to much faster network upgrade cycles, 2 to 3 years as opposed to 5 to 7. Reducing OpEx. This is actually one of the things, the standardized hardware, software, and platforms, okay, management efficiencies between 1 to 10 and 1 to 100 and 1 to 1,000. This is absolutely doable. In fact, I think you can actually do much better than this. And the reason I say that is because in 1991 and 92, I was working at Chevron building their IP network. I also worked in the group that managed Unix servers for Chevron. Chevron has a lot of Unix servers. They develop a lot of software. We had tens of thousands of Unix machines. We had 12 administrators, 12 Unix administrators for all of Chevron. Okay? That's a pretty good ratio. All right? If we could do it in 1991 and 92, we ought to be able to do better than that today. And we didn't have any of the tools and platforms that we're talking about here to do that. By the way, Chevron is unique. I've never run into another company that pulled that off. NFV is, we talked about this a little bit. I took a slide out that I should have left in there because it was graphical. But what you're doing is that top layer where we were talking about applications, we wind up starting to put in there some of the functions of the network, routing, caching, DNS service, security, intrusion detection, whatever, okay? And we wind up providing those as software, okay? That's the point of NFV, and it gives you tremendous flexibility in a lot of ways. Not only flexibility to do your architecture and deployments, but also flexibility, instead of just, that's kind of a vertical flexibility in terms of what you're doing, it also gives you a horizontal flexibility in terms of being able to add capacity. Because now you can scale these things out. If I need, I've done this a lot. 5 years ago, I built a pretty interesting big data analysis system. And we built it in such a way that it would elastically expand. Amazon gives you some really cool APIs that let you just bring in as many servers as you need. When I was doing really heavy analysis, if it turns out I needed more, we'd just sit there and keep adding storage servers. I need faster storage? Great. We had storage servers. That'll parallelize. It'll speed up the access, and you can do that. We're getting the same capabilities here in the network, and that's really, really neat. So these are virtualized network functions. These are those server-type things. These are VNFs, okay, that are sitting on top of the network function virtualization infrastructure. I think it's really confusing, personally, that these acronyms are the same but reversed, but I didn't come up with this stuff. And then this one is a really important thing to understand, too, because this is another one of the trends you want to pay attention to. This is called MANO, Management and Orchestration. As I said, you have to have automation to deal with the complexity involved in these networks, because you are deploying literally, even in a fairly simple SDN, you're deploying probably thousands of virtual images out there, even in the kind that would just be in a data center. The carrier guys, that scares me, okay? What you guys are doing is really, really, really impressive. This has to be integrated with operating support systems and business support systems. I'm not going to go into that too much, except to say that you have to have that. And we need these. These are the infrastructure, but they will not and cannot be fully leveraged until those other applications, especially your carrier guys, where you guys have to worry about billing and tracking and doing some interesting stuff like that. Okay, your back-end systems are going to have to be made aware of some of this, provisioning, all that kind of stuff. These are some challenges for carrier operators. I'm going to leave that for now. You can just read that in the slides because I'm running out of time here. Let's talk a little bit about some of these things, some of these protocols. We'll get into some of the diagrams here. OpenStack is one of the things that is this is providing that northbound API interface. This is one of the things that's doing that. Give you an idea of what's being done there. This was originated in 2010 by Rackspace and NASA down in Houston, Johnson Space Center, to develop kind of an infrastructure to duplicate the neat stuff that Amazon was doing in Amazon Web Services. If I sound like a fan of Amazon, it's because I am. They have awesome engineers, and at any given point in time, they're 2 to 5 years ahead of everybody else in the world, okay? One of the reasons I like to use them. I have not bought a server in over 15 years for any of my clients, okay, at all. Everything I've done has been in the cloud virtualized, usually with Amazon. It's amazing. But these are some of the things they do: compute, networking, block and object storage, orchestration, workflow database, elastic map reduce, bare metal stuff, messaging, shared file systems, DNS search. Those are all things that are built into the OpenStack cloud operating system. Now, Amazon does that too, but they've got their own APIs, which, like I said, are about 2 years ahead. OpenStack still is really good, and it's maturing to the point that it's very, very good for doing a lot of this stuff. One of the things that's interesting is what you get when you get this idea of doing NFV service chaining. Today, if you've got multiple services on your network, and those are provided by appliances, you have traffic running through all of those boxes, whether it makes sense or not. Okay? In this example, you've got, you may have a video optimizer, a content filter, a firewall, and NAT. Okay? All of your traffic is going through all of those things in series because this one's built by one vendor, this one's built by another one. Even if they're built by the same vendor, it's still probably a separate box. Okay? And so what happens is each of these boxes has to have the capacity to handle the maximum traffic, which is really expensive and really stupid, especially for some of these, right? All your data traffic's going through your video optimizer. Did you really want that? Probably not. Okay, the vast majority of the packets are flying through that thing untouched. Didn't make any sense. All right, with this idea of NFV service chaining, for each connection, and this is this is showing it for a carrier perspective from with a client device out here. I can choose whether I need to go through the video optimizer, the content filter, the firewall, or the NAT, and as I build these, I can define through tags or through a database that's defined a priori, or through inspection and analysis of the traffic, I can determine what functions are needed and route that on the fly. Okay, that's one of the cool things. It's one of the reasons you're going to see this happen. This has to happen. It's really not an option. We've talked a little bit about SDN and NFV, and a lot of people get them confused. They are not the same thing. They are not necessarily reliant on each other, but they work very, very well together. And I think in the real world from here on out, you're pretty much going to see them travel in packs. You're rarely going to see one without the other. SDN can be somewhat useful without NFV, but really you're going to want it. And then this is just basically saying open innovation is kind of working with the three of these to do this. Today, you do this in hardware with devices, and this is buried in there. We've got a router here that is connecting up, some private IP stuff to a customer. Data plane and control plane are not separated. They're tied together at every point. In an NFV world, one of the things that happens is we flip this around. We've got this open flow capable switch now. And so the router application is no longer, routing isn't happening in a router. We've got a router application running virtualized on a service that's doing the routing between these, okay? Now you'll notice that now we've got the control path doesn't flow through all here. Now the control path only has to go through part of this, all right? The data is still doing this little loop though, and that's not optimal. There's a way we can get rid of that, okay? When we throw the SDN and the NFV together, I can now tell it, oh, by the way, just run that traffic direct. There's no reason the data should go back up here again to do the routing. I'm going to download your routing policy, which is essentially a bunch of forwarding tables into the device, and you're going to do that. Now, these are forwarding tables that work at far more than just layer 2 and layer 3. These are things that work across multiple layers in the protocol stacks. This is expensive dedicated hardware goes away. You move it from an expensive location in a dedicated platform to an optimized location. And this is, we talked about this yesterday, some of the stuff that Ian was talking about, some of the stuff the panel was talking about, where we're seeing servers and radios move out. The radios are moving really close to the antennas, okay? And we've got baseband processors moving back to a data center on the other end of a fiber miles away, okay? This is the kind of technology that's letting you do that stuff, or to fully take advantage of it. This is a great little chart. I'm going to leave it up here for a second because it talks about some of the difference between these, okay? This is basically you separate the control and networking plane, or the data plane. This is relocating the functions to commodity appliances. And protocols, NFV, I wouldn't say none yet, but this is an older slide. I'm going to leave this out, but this is kind of interesting. These are some of the things that are going on. Again, you can look at the slides and get to that. this is about MANO, the management and orchestration. Netcracker recently came out as top ranked in a recent report that was released by or through RCR Wireless. They didn't do the work with somebody else's report, but I found it there. Again, automation is vital, and I'm out of time, so we're just going to go into this. For resources, pay attention to the Open Network Foundation, to ETSI, the Linux Foundation. SDX Central is more of a blog site, news site sort of thing. Pay attention to that one. There's a lot of good information there, especially if you don't want to get super technical but want to keep your finger on the pulse of what's going on. For those of you who want to get a little bit more technical, Verizon has got this is really good. I mean, it's a 220-page document, but it's really, really good. Okay, it's the first published architecture that I've seen for SDN and NFV. It's very involved, very detailed, pretty well thought out. Okay, they did a really good job on this. So if you really want to know a lot about the details, this is an excellent resource. Again, the ONF has this OpenFlow-enabled SDN and network functions virtualization document. This typo is not a typo. That's actually a typo in the actual URL. So that's why this little note here. That's it. Questions? Everybody understood it perfectly, right?
You talk about the SDN and NFV networks being built on open source, leveraging a lot of that. Does that necessarily mean that the carriers are outsourcing the integrity and the security of their systems?
I would say not really, okay? To the degree that these days everything is using open source to some degree anyway, okay? The internet protocols are open source. That was kind of the original, great open source experiment. The internet itself, BSD Unix, which kind of grew up and implemented the internet protocols for the first time. Those are open source. The rise of Linux, almost all the servers out there, unless you're running business applications where you may have a requirement for Windows servers, the vast majority of servers on the planet today are running Linux. Okay, the vast majority. That's open source. Okay, we're running open source platforms and applications. The advantage of open source is the advantage of it's like you're trying to decide, am I going to build my own engine for my car, or am I going to use somebody else's? Or maybe I'm going to buy a complete car, okay, instead of trying to build my own. Open source lets you do that, and you don't have to master all of that. Every time any company, even really large organizations, try to build all this stuff vertically, and this is what you've seen. I'm not trying to slam companies like Cisco and Juniper and those guys, but they've always tried to build this stuff vertically, and the problem is, I don't care who you are, I don't care how good you are, I don't care how many resources you have as a single corporation, none of us is as good as all of us. And so what you wind up with is there is some part of that stack that you build to solve your problem that sucks nasty green pond water, okay? And there's just no way around it. And with open source, it really becomes much, much easier to build a true best-of-breed solution. There are risks, okay? There absolutely are. I mean, we saw this a year or two ago with the OpenSSH stuff and some of the vulnerabilities there, where there were vulnerabilities that were, that had remained latent for a long time. So yeah, it's not risk-free, but I don't think it's a huge risk, and I also think one of the principles behind open source, and it failed in the case of OpenSSH, okay, but one of the principles is, with enough eyes, all bugs are shallow. We've got a lot of really smart people looking at building these protocols who know what they're doing. That's a good thing, and I think it will produce better code than we could get out of any much smaller group trying to perform the same operations.
I'm in agreement about when it comes to open source, and I think one of the assumptions it makes is just the same assumption that you mentioned earlier in your speech, was about originally the network was designed as a closed network where everybody trusted each other. The system didn't need to self-monitor. Open source is almost the same way. If you have people that can join in and inject some type of exploit into the system and nobody's checking.
Yeah, I mean there is a potential for that. Okay, and in fact it's actually worse than you think. If you want to read something truly scary, Ken Thompson, one of the guys who was one of the inventors of the C language and Unix at Bell Labs, okay, wrote a paper, gosh, I think it was back in the late 60s, early 70s, maybe early 70s, called On Trusting Trust, okay? And it raises a really interesting point. His point is, if you can't trust the compiler, you can't trust anything that it generates. Basically, his point is, a compromise at any point, especially a very early point in the process, can compromise everything else. You can build a compiler that will always put a backdoor into something and no one would ever know it, okay? And if you build that in to a compiler that is then used to compile safe code, it will still do that, okay? The lesson behind that ultimately is, unless you trust every step of what you do all the way back to the very beginning, you can't trust anything. That's a hard lesson, okay? And most of us kind of ignore that and hope it isn't really completely true, but it is. The good news is that, you know, these things probably aren't compromised by anybody other than the NSA. So, yes.
One question concerning ARM. You talked about a lot of excitement around ARM, and I'm just curious from a competitive perspective if you can give some more insight into your excitement around ARM and knowing that ARM was just purchased by SoftBank, I believe. Mm-hmm.
Well, first of all, ARM is unique in that, unlike other CPU architectures, okay? I mean, we have the x86 architecture, but for all practical purposes, we really only have two people doing anything with it, okay? We've got Intel and AMD. There are other people that make, lots of other people that make x86 chips, but they're not particularly influential in the marketplace. ARM is interesting because ARM proper doesn't make anything. They don't make chips, okay? They make IP to make chips. And a lot of people license that IP to make their chips. Apple, Samsung, Qualcomm, you know, Broadcom, whoever, okay? ARM cores are in everything now, and they're cheap enough to license that they're showing up in everything. So I think that's, one of the reasons I'm excited about that is because you have more competition, because you've got that broader range of companies that can provide solutions based on this common technology, and because once you've written a compiler for a particular generation of the ARM architecture, it will work pretty much on all the other ones with minor modifications, sometimes no modifications, okay? That's really cool. It's really neat. It kind of, it amps up this whole white box aspect. The other reason is, like I said, just in terms of, it's a question of momentum. In 1999, I went to the CEO of the company, the consulting company I was working for at the time, and I said, we need to get into Linux. And he said, no, we're not doing that. And I was right, because one of the things I point out was Linux isn't better than anything else, but it's getting better faster than anything else. That's the situation that ARM is in today. It's not, it actually probably arguably for some things is better, but because of the pressures and the whole ecosystem and the trillions of dollars, literally, that are going into an ARM ecosystem on the mobile side, there's a lot of benefit there that can swing back over and benefit the server side, and we're just now starting to see it. It definitely can be done. There was some of you may be familiar, who are here in Austin, may be familiar with a company here in Austin called New Isis that went under a few years ago, and it was a real shame because New Isis had built a really interesting high-speed backplane interconnect fabric for servers. It made it into the HP Moonshot servers for x86, but the company went bankrupt before they could launch the ARM version of it, which would have been really, really interesting. We're starting to see that happen. Other people are starting to do that and pick up where they left off. So I think you're going to see a push to ARM-based servers. One of the biggest reasons is the Intel stuff isn't very efficient. And so you wind up seeing, you know, you're burning more power cooling stuff now than you are running the devices in a lot of cases, okay? It's silly. And so if we can cut the power consumption, there's a huge win there.
I want to take the last question, though, myself.
Okay.
Because I put it back to kind of like a key slide for a lot of guys in the room here, is that by going to this system, we're looking at equipment upgrades of every 2 to 3 years instead of every 5 to 7. So we're talking about a lot faster change outs in the network in terms of equipment.
Absolutely.
And if you go to the next slide, these things are delivering efficiencies on management, which is a huge cost, from 1 to 10 to 1 to 100 to 1 to 1,000, we're talking about a lot of obsolescence going on in the existing way of doing things compared to making this jump to the next generation. So
Absolutely.
this is going to have a lot of impact on the things that you guys.
This is
care
going to
about.
affect everything that everybody building networks does. There's no question about it.
Okay, well, thank you so much, Deb.